Okay, with this video we're now going to be discussing a little bit about what actually happens when the C value changes and when the A value changes. So up until now we've been dealing with mostly y equals x squared and y equals negative x squared. We introduced in the last video, what happens when the value on the outside gets bigger. Okay, so as it gets bigger. And we also introduced what happens when the value on the outside gets smaller. And if you remember, and hopefully you do, that the bigger the number, okay, the thinner the graph, the smaller the number, the wider the graph. Okay, and if it was to do with a negative, with a big number, big negative number is narrower, negative smaller number is wider. Okay, but now we are dealing with what happens when this C changes and the A changes at the same time, but we're mostly dealing with we're dealing with the C first. Okay, what I want you to do is do what it says, use a graphic calculator. In your case, you are going to be using what's called Desmos. Okay, Desmos is a program that you can get on your iPad, online or an app, and you are just going to simply type these equations in. Y equals x squared, y equals 2x squared plus 1, y equals 2x squared minus 3. Okay, do that please. Now what you should hopefully notice, and I'm just going to remove these down below here so I can hopefully reinforce what you should have been seeing on Desmos. But what you should have been seeing was the y equals 2x, let's do the first one. Let's pretend that this is y equals x squared. Okay, when you did y equals 2x squared plus 1, what should have happened is the parabola should have got narrower, but it also would have gone through here at 1. Okay, and when you graphed y equals 2x squared minus 3, what you should have noticed is the width of the graph was the same, but this time it crossed at minus 3. Okay, so in other words, the number here, that C, okay, refers to the movement of the parabola up and down the y-axis. So in other words, if I have a graph y equals x squared plus 1, it will cut at 1. If I have a graph y equals x squared plus 2, it will be the same graph but just moved up to cut at 2. If I have y equals x squared minus 3, same graph but it cuts at minus 3. So all it does is move up and down the y-axis. Have a little practice again and type in a bunch of different numbers using the Desmos. Okay, so once again, which we talked about in the previous videos, but now it's asking you to type these two equations in as well. Well, it's actually asking you to type that one in, but you've already got that one on there. You just got to delete the other two. This is what we refer to as our basic parabola. Okay, everything comes from that parabola, and then we draw the others in relationship to that. So, for example, when you draw y equals x squared and then go and do a half x squared plus 3, you'll find that your graph will get wider, but it will also cross at positive 3 on the y-axis. Just as when you go to draw this graph, because a fifth is smaller than a half, your graph will actually get wider again, but, and my mistake, I drew it badly. Okay, it will get wider again, but it will cross at negative 4. So a few things. So to sort of sum up everything, if I was to have a basic graph of y equals x squared, and this is actually what you can do in an exam. If they say draw y equals x squared, I can just draw what I think y equal x squared is, and then call that 0. And of course, when x equals 1, y is going to equal 1. So that's 1 there. And the same on this side, okay? So that's 1, 1 there. So you can actually sort of state that. Now, what we've learned is that as the number gets bigger, my graph gets narrower, but in this case there's no C value, so it still crosses at the 0. So this would be y equals 2x squared, for example. If I had a graph y equals a half x squared, it means that my graph now gets wider compared to the first one, y equals x squared. So now it gets wider, but it still crosses through at 0. Sorry, my sketching isn't the best. Okay, so that's the blue one. That's the red one. Okay, and I'll just get rid of that tick because that's the black one. All right. Just the reverse happens if it's a negative. Now, the other thing you need to be aware of course, is as soon as I add in, for example, y equals 2x squared, but then put in, say, minus 3, it is the same width as the red one, but it now crosses at minus 3. So it's the same sort of width, but it now crosses at minus 3 because that has a minus 3 on it. Okay, so this next example is just showing it. Okay, and you can just match them together really, but y equals x squared, 1, there's no negative, so we know it's going to be concave up. Because there's no value at the end here, we know it's going to cross at 0, 0. Okay, so in this case, y equals x squared is there. With this one, y equals x squared minus 4, we know it's going to cross the y-axis at negative 4, so that's going to be the blue one. On the third one, we know it's going to cross the y-axis at plus 2, so that's going to be the red graph. If you look over to part B, straight away, negative. Okay, the negative in each of these means that it's going to be concave down. So you'll notice that all of these below are concave down. But this first one is not only concave down, but it's concave down at 0, 0. Okay, you've got no choice. It has no number in front of the x and has no number after the x squared. Okay, whereas when we go to do the minus 4, it means it's concave down but crosses at minus 4, hence it being the red graph. And then the next one at plus 5 means it crosses at plus 5, so therefore it's going to be the blue graph.